So section 6.3 is more on counting methods, and we're looking at some more advanced counting methods, in particular permutations and combinations. So to get us started with this, let's pretend we have a table, and on this table is a phone, the switch, an old He-Man figure from the 80s, for some reason a spool of thread, and a disembodied foot with a brace on it. And what I want to do is count the number of ways that I can choose objects from this table and take all of them off. I want to count the number of ways I can choose all 5 of these objects off the table one at a time. So, starting out, I have 5 different things I can choose from. So let's just suppose that I take the iPhone off first. So once I've made that choice, before I take the iPhone off, I have 5 different objects I can choose from. And after I make that choice, I have 4 objects left to choose from. I have the disembodied foot, the spool of thread for some reason, He-Man, and the switch. Right now, I make another choice, and I have 4 choices, and now I'm going to take off the spool of thread. Once I've done that, I have disembodied foot, He-Man, switch, so there are 3 objects to choose from. So multiply that by 3. Now I'm going to take the foot off, and that's going to leave me He-Man and the switch. So now I have 2 objects left to choose from. So I'll multiply by 2. So let's take He-Man off. No, let's not. Let's take the switch off. This doesn't matter for the math. I just want to be left with He-Man. Right, and now I have 1 more thing left to choose from. So I'll multiply this by 1, and then we'll take He-Man off. Right now, the reason that I'm multiplying 5 times 4 times 3 times 2 times 1, that comes from that fundamental counting rule, that multiplication principle from section 1. I'm counting the number of ways I can take objects off the table one at a time, and so I'm multiplying, and the choices go down each time. And so, as you all know, 5 times 4 times 3 times 2 times 1 is equal to 5 factorial. Right? That's the notation we use for 5 times 4 times 3 times 2 times 1. So that's the number of ways I can choose all 5. If I have 5 things on the table, this is the number of ways that I could choose all of them one at a time. There are 5 factorial ways. Now, before I go on to the first definition of this section, I do want to point something out. So let's now suppose we're starting off with an empty table. I'm going to erase all these calculations we did before, and I want to figure out how many ways I can choose 0 objects off that table. Now, one way to think of permutations as far as a definition goes is it's the number of ways to choose objects off a table. So n factorial, which is equal to n times n minus 1 times n minus 2 down to 3 times 2 times 1. One way to think of this as the number of ways to choose n objects. So the question arises, what is 0 factorial going to be? Well, think of it like this. I have nothing on this table. How many ways can I pick up 0 objects? And the answer to that question is 1. There is 1 way that I can pick up 0 objects. And that 1 way is I don't pick up anything. So 0 factorial is equal to 1. And if that bugs you and you don't like that reasoning, we can talk about it in class or something. And if it does bug you, and it does bug some people, just think of this as a definition. We define 0 factorial to be equal to 1. All right?